Welcome to Access Control Lists, the sixth video in the TELABS Optical LAN System Architecture and Application series. In this video, we'll explore the basics of ACLs, their types, and some real-world applications. The topics covered in this video will include an introduction to ACLs, the process for creating and applying ACLs in Panorama, and a list of some common ACLs used with the TELABS Optical LAN system. Access control lists, or ACLs, are network filters used by routers and switches to permit or deny data flows into and out of network interfaces. When an ACL is configured on an interface, the network device analyzes data passing through the interface, compares it to the criteria described in the ACL, and either permits the data to flow or prohibits it. There are two types of ACL filters, basic and extended. Basic ACL filters are typically permit actions that look at either the source MAC, source IP, or both. When a basic permit ACL is applied to a VLAN, the default ACL action of the VLAN should be a deny action. That is, all packets will be discarded unless they meet the requirements of the permit action. Extended ACL filters are typically deny actions and look at deeper packet characteristics, such as telnet or FTP. If an ACL contains only deny actions, the default action of the VLAN should be permit. That way, all traffic is permitted unless the ACL prohibits it. Using global ACLs will apply a set of rules to all UNI ports on the OLT. A global ACL optimizes resource usage by applying a single instance of the ACL across the entire OLT, rather than duplicating it for each port. Blocking DHCP traffic on the access port is an effective example of implementing a global ACL to enhance network security. Each VLAN has a default posture. This defines the basic security posture of the VLAN. The ACL mode indicates the security posture. The ACL mode is set in the switching application under the VLAN Properties tab. ACL modes can be set to disable all ACLs, basic ACL default deny, extended default deny, and extended default permit. When the ACL mode is set to disable all ACLs will be deactivated on the applied VLAN. All packets are permitted to flow across the VLAN without ACL restriction. This setting is often used to temporarily disable ACLs for the purpose of port testing. When using the basic default deny ACL mode, by default all packets will be dropped unless explicitly permitted by the ACL. ACLs must be used to permit the traffic that is desired to flow on that VLAN. Basic ACLs are limited to filtering on the source MAC and source IP addresses. Like basic default deny, extended default deny will drop all packets on the VLAN unless explicitly permitted by an ACL. Extended ACLs can filter on many of the fields in an IP packet but require more resources and fewer can be created. An extended default deny VLAN will allow either basic ACLs or extended ACLs. Using extended default permit, all packets will flow on the VLAN unless an ACL causes them to be denied. Both extended and basic ACLs are allowed using this VLAN mode. Different areas of the network or building may have different access policies based upon where the port is located. This can be accommodated by the NAC profile that is assigned to the port. Each NAC profile can have a different access policy, which is enforced by the Service Profiles ACL. The example here demonstrates an architecture where the policy NAC profile can be assigned based on location and used to enforce policy on the same VLAN. This allows for very flexible architecture which still maintains security. It should be noted that the best policy is often to isolate users to maximize security, but this example shows how a hybrid approach can be used that simplifies network configuration and routing in small networks. To create an ACL, select Profiles from the main menu. Select Services and the ACL tab. Select the Create a New Profile icon. After the ACL profile is named, you can then create rules or filters to add to the ACL. The following are some examples of some common ACL filters that can be implemented. First, we'll look at some basic ACLs. Basic ACL filters are always permit actions and will permit a specific source MAC, IP, or groups of MACs and IPs to be allowed on the port. When the source MAC is set for sticky MAC, one or more MAC addresses will be learned from the device or devices on the port and then persistently stored in the forwarding table. In this ACL example, the filter is configured to allow a sticky MAC and only allows a single device to be attached to the port. Using this ACL filter, MAC addresses are learned and remembered across system reboots and can only be removed by a manual action by an admin user. This allows the advantages of statically configuring MACs without having to manually enter all the MAC addresses by hand. The static MAC feature is similar but allows the user to explicitly configure the MAC or list of MAC addresses that are allowed on the port. This example shows an ACL that will only allow the entered MAC addresses to pass traffic on the port. The /24 indicates only the first 24 bits must match. The first 24 bits of a MAC address are called the Organizational Unique Identifier and typically indicate the manufacturer of a given device, such as Dell. Typically, both a sticky MAC and static MAC filters are applied to a default deny VLAN. The authorized MAC ACL is used to only allow ports that have been authorized by 802.1x MAB to be able to pass traffic on the port. This ACL works with 802.1x to grant access to default deny VLANs once Radius has given an access accept message when authorization is attempted. It is possible to expand the basic ACL permit filter to also bind a source IP address or subnet to a given MAC address. If no corresponding MAC address filter is needed, the MAC address filter can be set to any MAC to allow the ACL to only permit a specific host access to the network. The bound source IP, when defined with the /32 notation, indicates that only that address is allowed. To prevent a user from using an IP outside of their given subnet, the bound source address may use a /24 or other CIDR notation. This will only permit the user to use an assigned subnet. Like all permit filters, this ACL is only valid if it is on a default deny VLAN. Extended ACLs allow you to do both deny and permit actions. In this example, we want to deny a specific host on the port. It is similar to the allow specific host filter, but the ACL type is set to extended ACL and the action is set to deny. Now, any traffic from the specific source IP address or subnet will be denied. This filter requires that the VLAN be an extended permit VLAN unless there are other permit filters in place. Another use for the extended deny filter is to block the use of specific services on the service port. This ACL will deny the service of Telnet from being used. It must be set for a filter type of IP version 4, a protocol of TCP, and be directed at packets going to port 23. With this filter in place, packets that contain a destination port 23 will be denied, thus suppressing the user's ability to use Telnet. Similarly, FTP services can be denied by setting an extended ACL to deny destination ports 20 and 21. To only allow FTP traffic on the port, the previous ACL can be changed to an action of permit. This will only allow active FTP sessions to the server on the service port. For this ACL, the VLAN is a default deny, and only FTP traffic is permitted. This ACL will prevent a port from being able to act as a DHCP server and offer IP addresses. This is done by creating an extended ACL with the deny action of the source port 67. This prevents inadvertent or malicious actions by users. Typically, IP addresses should only be assigned by servers in the distribution or core of the network and not from endpoints attached to ONT ports. This concludes this video. In it, we have discussed an introduction to ACLs, the process for creating and applying ACLs in Panorama, and a list of some of the common ACLs used with the Telebs optical LAN system.